Welcome to the world of high-speed data transmission and part 1 of our 400 gig coherent transceivers crash course series. Coherent pluggables are revolutionizing the way we think about data connectivity. As high-definition video streaming, online gaming, and other data-intensive applications constantly press networks to provide higher bandwidth to accommodate increasing data demands. With mounting pressure, what do network operators need to meet these demands? Enter coherent pluggable transceivers. Coherent pluggable transceivers help combat these challenges by combining coherent optics with the convenience of pluggable form factors. Let's take a peek under the hood of these compact yet powerful devices. Coherent pluggable transceivers are compact optical modules, integrating coherent optical technology and DSP into a form factor that can be easily plugged into switches, routers, and other network equipment. But what exactly is coherent technology? Coherent technology employs sophisticated modulation and encoding techniques that enhances long-reach data transmission over fiber optic networks. In the context of coherent pluggable standards, these modulation and encoding techniques play a central role in defining the specifications and performance requirements of pluggable transceivers. Modulation. Non-coherent optics will typically use simpler modulation schemes, such as NRZ or PAM4, while coherent optics employ more advanced schemes, such as QPSK or QAM. The advanced modulation techniques used in coherent optical communications leverage the phase and/or amplitude of the optical carrier signal in multiple polarizations. These new formats are essential for achieving high data transmission rates and for improving the spectral efficiency of optical communication systems, including phase shift keying, or PSK. PSK modulation techniques such as QPSK and 8PSK modulate the carrier signal by changing its phase. QPSK is widely used in coherent optical communication systems, especially in 100 gig and 200 gig coherent transceivers. Quadrature amplitude modulation, or QAM. QAM is a more sophisticated modulation format that combines both phase and amplitude modulation. It allows for the transmission of multiple bits per symbol by modulating both the phase and amplitude of the optical carrier signal. Figure 5 shows a practical example of a 400 gig ZR coherent transceiver using 16 QAM modulation without noise, the left image, and with added noise, right image. The noisier the transmission, the harder it will be for the receiver to differentiate between each symbol transmitted, and errors will occur. Another important technique employed in coherent optics that allows an increase in the data rate, also used in wireless transmissions, for example, is dual polarization, or DP. In dual polarization techniques, the same signal is transmitted in two orthogonal optical polarizations at an angle of 90 degrees, effectively doubling the amount of data transmitted. Error correction techniques. Error correction techniques have been part of long-range data transmission systems for many years, and they become even more relevant with the arrival of 400 gig pluggable optics. In forward error correction, or FEC, redundant information known as parity bits is added to the original data stream before transmission. Different types of FEC have been used in optical communications for various data rates and applications. In the current environment of coherent pluggables, the main FEC types are conjugated FEC, or CFEC, used in 400 ZR standard, Open FEC, or OFEC, part of the Open ROADM and Open ZR Plus specifications. Staircase FEC, or SC FEC, used for the 100 gig base ZR standard. Watch part 2 of our 400 gig coherent transceivers crash course series, where we will discuss coherent pluggable standards, specifically 400 ZR and Open ZR Plus and their inner workings.